Rizal General Comprehensive High School, Senior High School. Welcome to another fun learning episode on Earth and Life Science. Before we proceed to our lesson, let us recall first the stress on rocks. Can you still remember the three different types of stress? Very good! The three types of stress are compression, tension, and shearing. Moving on for today's lesson, we will describe the types of folding and faulting. Have you visited some amazing landforms? Let us look at the scenery. Do you know how they are formed? Each of them formed from constant movement of the Earth's crust. Now, let's dwell on the processes of folding and faulting. Get ready to discover and be amazed on some of its importance and effects of these Earth's movement. Earth's surface is composed of tectonic plates that are constantly moving. The plates result in deformation of the Earth's crust. The different types of stress that act upon rocks play an important role in the movement of plates. The first type of Earth movement is folding. It results from the compression of rock because of high temperature and pressure from the interior of Earth. Bending, curving, crumpling, or buckling of rocks into folds are usually visible on rock strata. Folding can also happen in oceans and seas. Do you know the different types of folding? Monocline, anticline, syncline, overturned, and recumbent. The first type of folding is monocline. It is a step-like fold in rock strata consisting of a zone of steeper, deep within and otherwise horizontal, or gently dipping sequence. Can you name an example of monocline? Example of monocline is the water pocket fold in Capitol Reef National Park, USA. Now, let's have the second type of folding, anticline. It is a type of fold that is an arc-like shape. Can you give me an example of anticline? Very good! Blue Ridge Anticlinorium of Northern Virginia is an example of anticline folding. The third type of folding is syncline. It is a downward fold of the rock. Syncline formed when tectonic plates move toward each other, compressing the crust and forcing it upward. One example of syncline is Southland Syncline of New Zealand. The fourth type of folding is overturned. It happens when one fold is pushed over the other limb due to increasing pressure. Can you give me an example of overturned folds? You got it right! Wasatch Mountains of USA is one of the examples of overturned fold. Now, we are down to the fifth type of folds, which is recumbent. It is an extreme type of overturned fold in which the actual plane acquires an almost horizontal. Can you name one example of recumbent fold? Very good! It is the Miluk Haven, Cornwall of United Kingdom. So, we are done with the different types of folding. Let us proceed to the second type of earth movement, which is fault.
Fault is a fracture or zone of fractures between two blocks of rock. Faults allow the blocks to move relative to each other. This movement may occur rapidly in the form of an earthquake or may occur slowly in the form of creep. Faults may range in length from a few millimeters to thousands of kilometers. Most faults produce repeated displacement over geologic time.
There are three types of faults. Can you name them all? Correct! These are normal fault, reverse fault, and transform fault. Let us start with the normal fault. Normal fault occurs when rock is being pulled apart due to tension force. In this type of fault, rock generally moves down. Can you give me one example of normal fault? Very good! Sierra Nevada fault of North America is an example of normal fault. Now, let's have the second type of fault, which is reverse fault. This happens when rock is being squeezed due to compression force. This type of fault generally moves up. Do you know the famous example of reverse fault? You got it right! It is the Rocky Mountains of Himalayas. We are now down to the third type of fault, which is transform fault. Transform fault happens when rocks slide past each other in opposite direction. The San Andreas fault is an example of this. Now, we are about to end our lesson for today. Let us recap what we have learned. We discussed the different types of folds and faults. Faults constitute the twists and bends in rocks. There are 5 types of faults, and these are monocline, anticline, syncline, overturned, and recumbent. It's time for a short assessment of our topics today. Prepare a ball pen and a piece of paper to answer the following questions. You will be given 5 seconds to answer each question. Ready? Let's begin!
Number 1. It is a type of earth movement that forms cracks or fractures on the rocks. Letter A. Tension. B. Faulting. C. Folding. Or letter D. Compression. Number 2. It is a type of earth movement resulting from the compression of rock. Letter A. Tension. B. Faulting. C. Folding. Or letter D. Compression. Number 3. A one-sided slope connecting two horizontal or gently inclined strata. Letter A, monocline. B, syncline. C, anticline. Or letter D, overturned. Number 4. It is an upward fold on the rock. Letter A, monocline. B, syncline. C, anticline. Or letter D, overturned. Number 5. It happens when rock is being squeezed due to compression force. This type of fault generally moves up. Letter A, monocline. B, transform fault. C, reverse fault. Or letter D, normal fault.
Congratulations! We are done with our short quiz for today. Please submit your output to your respective subject teacher via messenger or email. And that ends our lesson for today. I hope you enjoyed and learned something. Again, I am Teacher Alice J. Calupas of Misamis Oriental General Comprehensive High School, Senior High School, Division of Misamis Oriental. Tune in for another learning episode next time. Goodbye!
Of Misamis Oriental General Comprehensive High School, Division of Misamis Oriental. I am your teacher for this episode on Earth and Life Science. Before we begin with our new topic for today, let us have a quick recall on our previous lesson. Are we all set? Good! In the previous lesson, we discussed about the 3 classifications of rocks. Can you name them? Wow! That's absolutely correct! We have igneous, sedimentary, and metamorphic rocks. Now, let us differentiate each one of them. Igneous rocks are formed from the solidification of molten rock material, lava, which flows out of a volcano. This lava cools and solidifies and becomes an igneous rock. An example is granite, which is used in making statues. Sedimentary rocks, on the other hand, are formed on or near the Earth's surface. If buried deeply, becomes compacted and cemented, forming sedimentary rock. An example is limestone, which is used in making cement. Lastly, metamorphic rocks are formed from other rocks that are changed because of heat or pressure. Earth movements can cause rocks to be deeply buried or squeezed. As a result, the rocks are heated and put under great pressure, thus forming metamorphic rocks. An example is marble, which is used as a sculpture material. Now, moving on for today's lesson, we will be discussing about Earth's internal heat. Are you ready for today's journey? If yes, then let's begin. Heat energy plays an important role in our planet. Heat is considered as one of the extreme factors to make our planet inhabitable. Without heat, our planet would be cold, making life impossible. We all have seen the Mayan volcano in pictures, movies, or even in real life, right?
With the thought of that volcano, where hot lava flows out, you might be thinking, how hot Earth must be inside. This heat could move continents, build mountains, and may cause volcanic earthquakes.
But the big question is, where does the heat inside of planet Earth come from?
There are two known sources of heat of our planet Earth, namely the primordial heat and radiogenic heat.
Have you encountered the word primordial? Correct! It means first created or developed.
Thus, primordial heat is the heat energy in the Earth's interior that is left over from the heating of the planet during its early formation. The major contribution of this internal heat is the accretional energy. This is the energy deposited during the early formation of a planet.
Where do you think primordial heat is originated? Exactly! The Earth's core is a storage of primordial heat that originates from times of accretion of Earth.
An analogy would simplify this idea. If you hit a hammer on a hard surface several times, what do you think would happen? Correct! The metal in the hammer will heat up, right? Kinetic energy here is then transformed into heat energy. This primordial heat is constantly lost to the outer silicate layers of the mantle and crust of the Earth through conduction and convection, which will be discussed in a short while.
The second source of heat in our planet is the radiogenic heat. This is the heat generated by the decay of radioactive isotopes of the elements.
Radioactive decay is the process in which an unstable atomic nucleus loses energy by radiation.
By the way, what is an isotope? Isotopes are atoms from the same element whose nuclei have a different number of neutrons and therefore differ in mass. The key point is that radioactive decay of isotopes in the mantle and crust is a continuing source of heat. An example is uranium, which is a special kind of element because when it decays, radiogenic heat is produced.
Radioactive elements exist everywhere on the Earth in a fairly significant concentration. Without the process of radioactive decay, there would be fewer volcanoes and earthquakes and less formation of the Earth's vast mountain ranges.
Now, let us briefly discuss the methods of heat transfer mentioned earlier. Conduction is the transfer of heat between substances that are in direct contact with each other.
This is the process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Heat from the Earth's core and radiation from the Sun is transferred to the surface of the Earth by conduction.
Convection, on the other hand, is a transfer of heat related to the movement that occurs within a fluid due to rising of hotter materials paired with the sinking of colder materials. This occurs because hotter materials have less density than colder ones. This happens at the mantle, but never in between the core and mantle.
The mantle behaves as a viscous fluid due to high temperatures. In the convection current, the mantle of the Earth moves slowly because of the transfer of heat from the interior of the Earth up to the surface. This results to the movement of tectonic plates.
Did you know that the heat of the core takes tens of thousands of years to reach the surface of the Earth? The Earth's surface cools from the outside, but the core is still made of extremely hot material. Now we have reached the end of our journey today. Let us recap what we have learned. We have discussed the two sources of heat in our planet Earth, namely the primordial and the radiogenic heat. Primordial heat is a heat energy in the Earth's interior that is left over from the heating of the planet during its formation. Radiogenic heat, on the other hand, is the heat generated from the decay of radioactive isotopes of the elements. We also mentioned the process of convection and conduction that takes place in the Earth's mantle and crust. Now, it's time to test your understanding of today's lesson. Prepare a ball pen and a piece of paper to answer the following questions. I will repeat each question twice, and you will be given 5 seconds to answer each question. Ready? Let's begin.
Number 1. What are the two primary sources of the Earth's internal heat? Again, what are the two primary sources of the Earth's internal heat? Number 2. What do you call the energy deposited during the early formation of a planet? Again, what do you call the energy deposited during the early formation of a planet? Number 3. True or false? Conduction is a process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Again, true or false? Conduction is the process by which heat energy is transmitted through collisions between neighboring atoms or molecules. Number 4. True or false? Without the process of radioactive decay, there would be fewer volcanoes and earthquakes. Again, true or false? Without the process of radioactive decay, there would be fewer volcanoes and earthquakes. Number 5. True or false? The heat of the core takes hundreds of years to reach the surface of the Earth. Again, true or false? The heat of the core takes hundreds of years to reach the surface of the Earth.
Okay, time's up. Congratulations! Now we are finally done with a short quiz. Please submit your papers to your respective subject teacher via messenger, email, or submission on your next module distribution. And that ends our lesson for today. I hope you have learned a lot in this session. Again, I am teacher Gisela Esquinas of Mogchs Senior High School, Division of Misamis Oriental. Tune in for another learning episode next time. Goodbye!
Good day, learners! I am Ma'am Claire and welcome to Earth and Life Science. Before we start with our lesson today, let us recall the planets in our solar system. Can you name the 8 planets from the closest to the farthest from the Sun? Very good! We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now, among the planets, what makes Earth unique? What is on Earth that is absent in the other planets? Do you want a clue? Look at these images. What 4-letter word describes the images? Correct! Life. There is life on Earth. But how does Earth support life? In today's lesson, you will recognize the uniqueness of Earth as the only planet in the solar system with properties necessary to support life. You will be studying the factors that make a planet habitable. There are 5 factors that we shall discuss. The first is Earth's location. The Earth is the 3rd planet in our solar system. Its distance from the Sun is 93 million miles, and it takes about 500 seconds for sunlight to reach the Earth's surface. This distance is enough to support life. As we have learned in our previous science lessons, the producers or the organisms that manufacture their own food utilize the energy from the sun and convert it into chemical energy that marks the beginning of food chains and complex food webs. This process is called photosynthesis. The distance between the Earth and the Sun is strategic enough to make photosynthesis work. If the Earth had been too close to the Sun, it would have been dry and lifeless, just like Mercury and Venus. If it had been too far, like Uranus and Neptune, it would have been cold and dark. This location also prevents it from planetary collisions. Our neighbor Jupiter is so massive and its gravity is so strong that it pulls the asteroids and other space debris towards itself, thereby protecting the Earth. The second factor is the Earth's atmosphere. The atmosphere is the gaseous layer that envelopes the Earth. It is composed mainly of nitrogen and oxygen. The atmosphere traps heat and keeps us warm. It also shields us from harmful radiation and provides chemicals needed for life. The presence of an atmosphere on Earth is related to the third factor, which is the Earth's size and mass. Smaller planets have weaker gravity to hold an atmosphere, while bigger planets with bigger atmosphere will most likely have a stronger greenhouse effect. The Earth's size is just right to hold a sufficient atmosphere. The fourth factor is the magnetic field. As the Earth spins, the flow of liquid iron and nickel in the outer core produces a magnetic field. This shields the Earth from solar winds and other space weather. And fifth is the presence of water. On Earth, water exists as gas, liquid, and solid. Life benefits from the cooling effect of water. In summary, the 5 factors that make a planet habitable are its location, atmosphere, size and mass, magnetic field, and presence of water. Before we end, I will leave you with an activity to answer. Prepare a pen and a piece of paper. The title of our first activity is Crash Landing. Here is the scenario. A meteoroid has hit your spaceship. Luckily, you are passing through the Mogchs system, which consists of sun-like star surrounded by 7 planets, some of which have moons. Your ship has barely enough fuel and guidance ability to allow you to select a nearby place to crash land. Shown on the next slides are the profiles of each of the planets and moons in the Mogchs system. The information is sketchy, but it's all your sensors had time to collect before going offline due to the damage caused by the meteoroid. Question number 1. In which planet will you land? Why? Question number 2. Why did you not choose the other planets? Write your answer on your paper and submit it to your teacher. So this has been Claire Arrow, your teacher. See you next time for more interesting videos on science. Goodbye!
Good day, grade 11 students. Nice to see you again. I am teacher Gisela Esquinas from the San Luis Oriental General Comprehensive High School, Senior High School, Division of Miss San Luis Oriental. I am your teacher for this learning episode on Earth and Life Science. Before we begin with our new topic for today, let us have a brief recap of our previous lesson. In the previous lesson, we talked about the Earth's internal heat. We consider heat as one of the extreme factors to make Earth inhabitable. Earth's internal heat could move continents, build mountains, and cause volcanic earthquakes. Can you still remember the two known sources of Earth's internal heat? You got it right! The first one is primordial heat, which was gradually gathered together by means of dispersion in the planet during the early formation of the Earth. The second source of heat in our planet is the radiogenic heat. This is the thermal energy released as a result of spontaneous nuclear disintegration. There are different ways to transfer heat.
Conduction governs the thermal conditions in almost the entire solid portions of the Earth and plays a very important role in the Earth's surface. Convection happens at the mantle, but never in between the core and mantle.
Moving on for today's lesson, we will be discussing the changes in mineral components and texture of rocks due to the changes in pressure and temperature, which is known to be the process of metamorphism. Now that we know where the heat of our planet comes from, let us focus on the process of metamorphism. Are you familiar with the rock cycle? The rock cycle is a concept used to explain how the three basic rock types are related and how Earth processes over geologic time change a rock from one type into another. Plate tectonic activity, along with weathering and erosional processes, are responsible for the continued recycling of rocks.
The rock cycle is a group of changes. Igneous rock can change into sedimentary rock or into metamorphic rock. Sedimentary rock can change into metamorphic rock or into igneous rock, while metamorphic rock can change into either igneous or sedimentary rock.
We have already discussed the three types of rocks and how they are formed. I am sure that you already encountered the word metamorphism. Metamorphism is a change in the structure, texture, or composition of rocks subjected to conditions that are different from those which it is formed. It is from the Greek word meta, which means change, and morphe, which means form.
Metamorphic rocks form when rocks are subjected to high heat, high pressure, hot mineral-rich fluids, or, more commonly, some combination of these factors. Conditions like these are found deep within the Earth, or where tectonic plates meet. The process of metamorphism does not melt the rocks, but instead transforms them into denser, more compact rocks. New minerals are created either by rearrangement of mineral components or by reactions with fluids that enter the rock.
Pressure or temperature can even change previously metamorphosed rocks into new types. Metamorphic rocks are often squished, smeared out, or folded. Despite these uncomfortable conditions, metamorphic rocks do not get hot enough to melt, or they would become igneous rocks. Do you know the three main factors of metamorphism? Correct. This includes heat, pressure, and chemically active fluids. The heat perhaps is the most important factor because it provides the energy to drive the chemical changes which results in the recrystallization of minerals. The heat increases as the depth increases.
Pressure, just like heat, also increases with depth, and the buried rocks are subjected to the force or stress. Heat and pressure causes physical changes to buried rocks. Chemically active fluids enhance the metamorphic process. Usually, the common fluid which helps the chemical activity is water, containing ions in solution.
So what are examples of metamorphic rocks? Slate is produced due to low-grade metamorphism of shale, which is used for classroom blackboards and pool tabletops. Schist has mica crystals from metamorphism of clay and feldspar. Anthracite is the metamorphism of bituminous coal. Gneiss is produced due to high-grade metamorphism. And lastly, marble is formed through the metamorphism of limestone, which is used in the construction of building floors, walls, and counterparts. Now we have reached the end of our journey for today. Let us recap what we have learned. We discussed about the process of metamorphism, in which new minerals are created either by rearrangement of mineral components or by reactions with fluids that enter the rocks. Pressure or temperature can even change previously metamorphosed rocks into new types. It's time for a short assessment of our topics today. Prepare a ballpen and a piece of paper to answer the following questions. I will repeat each question twice. You'll be given 5 seconds to answer each question. Ready? Let's begin.
Number 1. What is metamorphism? Again, what is metamorphism? Number 2. What are the three main factors of metamorphism? Again, what are the three main factors of metamorphism? Number 3. Give 2 examples of metamorphic rocks that has commercial uses. Again, give 2 examples of metamorphic rocks that has commercial uses.
Congratulations! We are done with our short quiz for today. Please submit your output to your respective subject teacher via messenger or email. And that ends our lesson for today. I hope you enjoyed and learned something. Again, I am teacher Giselle from Misamis Oriental General Comprehensive High School. School, Senior High School, Division of Misamis Oriental. Tune in for another learning episode next time. Goodbye! Good day, learners! I am teacher Hannah Napitan of Misamis Oriental General Comprehensive High School, Senior High School, Division of Misamis Oriental. I am your teacher for this learning episode on Earth and Life Science. Before we begin for today's lesson, let us have a quick recap. What are the four subsystems of the Earth? Excellent! The four subsystems of the Earth are biosphere, atmosphere, hydrosphere, geosphere. What is the main point that you have learned about these systems? That's right! We have learned that even if the Earth consists of four different spheres, all of them interact with one another to keep the balance and harmony in the planet. Isn't it amazing? Amazing! Yes, it is! Now, I want you to look at these pictures. What word describe the images? Correct! They are minerals. So, our lesson for today is the properties of minerals. In today's lesson, we will identify common rock-forming minerals using their physical and chemical properties.
Have you ever wondered how minerals differ from rocks? How will you know if you are holding a mineral or a rock? A mineral is defined as naturally occurring, usually inorganic solid with distinct chemical composition and an orderly crystalline structure. Rocks are usually made up of two or more minerals. There are properties that will help us identify a mineral from rocks. These properties are luster, straight, cleavage and fracture, density, hardness, reaction with acids, fluorescence, and phosphorescence. Are you ready to explore these properties of minerals? Let's begin! The first property of a mineral is color. How does a mineral gain its unique color? It is the result of the reflection of visible light and the various elements composing the mineral. If a mineral is composed of elements that reflect violet light, then a mineral will appear violet. However, color is not an effective indicator of a mineral. Like quartz, it comes with different colors. which brings us to the next property. The second property of a mineral is luster. It is the ability of a mineral to reflect light from its surface. In other words, it is how shiny a mineral is. The third property is streak. Streak refers to the color of a mineral in powdered form. How do you get the streak of a mineral? Simple. Just rub a mineral in an unglazed ceramic tile to observe its streak. Always remember that metallic minerals have dark-colored streaks, while non-metallic minerals have light-colored streaks in general. For the next property, have you ever wondered why minerals come in various shapes and sizes? Well, it is because of the next two properties, which are cleavage and fracture. Cleavage refers to the ability of a mineral to split along a weak plane, forming flat surface. On the other hand, fracture refers to the capacity of a mineral to break along curved surfaces. If we break a mineral and it has a flat, smooth, and even surface, that is cleavage. So, if a mineral breaks bearing jagged and uneven surfaces, then it is considered as fracture. That explains why we have minerals in all sorts of shapes and sizes. The next property is density. Let us remember that density is intrinsic, which means that it is the same for all minerals no matter the shape and size of the sample. Diamond has a higher density of 3.51 grams per cubic centimeter, while Tal has a density of 2.76 grams cubic centimeter. We now know that some properties cannot fully indicate the identity of a mineral, but density can. In summary, each element and mineral has unique density that makes it identifiable from others. The seventh property is hardness, which is the tendency of a mineral to resist abrasion or scratching. The Mohs scale of hardness shows the arrangement of minerals from softest to hardest, which is measured in a scale of 1 to 10. Another useful property of mineral is reaction to acids. It is indeed a useful indicator. It can be used to identify carbonate and zeolite minerals, since minerals with carbonate reacts with acid. We are now in our last two properties, which are fluorescence and phosphorescence. These are amazing properties. Fluorescence is the ability of a mineral to glow when bounded with ultraviolet light. Imagine that you are in a dark cave. Then you see minerals with different colors at the cave walls. Would this be possible? It can be possible. It's because of fluorescence. Fluorescence has been used in mining, mineralogy, geology, and petrology. Take note that ultraviolet light is one technique that geologists use to search for minerals. The last property is phosphorescence. Would you believe that minerals glow? Absolutely. Some minerals would continue to glow even after a source of ultraviolet light has been turned off. It would be wonderful if you explore your surroundings, collect rock samples, and study their composition. Now that you have studied minerals and its common properties, surely you will be able to identify one. This might be a jumpstart for you to become a geologist or even a science teacher.
Wow!
That would be awesome. Now that we have finished the learning episode, it is time to check our understanding of today's lesson. Get a pen and a paper to answer the following questions. Are you ready? Let's begin! First question. What property describes a mineral's resistance to scratching? Correct! The answer is hardness. Second question. What property of a mineral describes the way it breaks into flat surfaces? Correct. The answer is fracture. Third question. What is the ability of a mineral to glow when bombarded with ultraviolet light? Very good. The answer is fluorescence. Fourth question. What is an intrinsic property of a mineral or any other element that helps identify real minerals from fake ones? Very good. The answer is density. Fifth question. What is the ability of a mineral to reflect light from its surface? Excellent! The correct answer is luster. That ends our lesson for today. I hope you learned many things. Once again, I am Teacher Hannah May Christine Binapitan of Misamis Oriental General Comprehensive High School, Division of Misamis Oriental. See you all in the next learning episode.
Misamis Oriental General Comprehensive High School, Senior High School, Division of Misamis Oriental. I am your teacher for this episode on Earth and Life Science. Before we start with our lesson today, let us recall the factors that make a planet habitable. Can you name the 5 factors? Very good. The factors are the Earth's location, the Earth's atmosphere, the Earth's size and mass, the Earth's magnetic field, and the presence of water. If you look closely at Earth from space, you may see that it is much more than rock and soil. This view of Earth should help you see why the physical environment is divided into 3 major spheres or subsystems: the water portion of our planet, the hydrosphere, the Earth's gaseous envelope, the atmosphere, and the geosphere. Our environment is characterized by the continuous interactions of air and rock and water, and water and air. The biosphere, which is made up of all the life forms of Earth, interacts with all the 3 of these physical spheres. In today's lesson, you will explain that the Earth consists of 4 subsystems, across whose boundaries matter and energy flow. You will be studying the subsystems of the Earth. There are 4 subsystems that we shall discuss. The first one is the hydrosphere. Do you have any idea what hydrosphere is? Yes, you got it right. This makes up all the water on Earth. Hydrosphere combines the Greek root word hydro, which means water, and sphere from the Greek word spira, which means globe or ball. Did you know that water is what makes Earth unique? Earth is unique in the solar system for its abundant surface waters. It's because of the hydrosphere that life flourishes on Earth. The second subsystem of the Earth is the atmosphere. It is derived from the Greek words atmos, which means vapor, and spira, which means ball or sphere. This is the life-sustaining gaseous envelope that surrounds the Earth. Do you know where the atmosphere is located? Correct! It reaches beyond 100 kilometers above Earth, yet 90% occurs within just 16 kilometers of Earth's surface. This thin blanket of air is an important part of the Earth. It provides the air that we breathe. It also protects us from the sun's intense heat and radiation. The energy exchanges that constantly occur between space, the atmosphere, and the Earth's surface produce weather and climate. What do you think would happen if Earth had no atmosphere? Exactly. Our planet would be lifeless. Many of the processes and interactions that make the surface such a dynamic place would not occur. For example, without weathering and erosion, the face of our planet might more closely resemble the moon. The third subsystem is the geosphere. This is the solid part of the Earth. Do you know where it is located? That is absolutely correct. The geosphere lies beneath both the atmosphere and the ocean. because the geosphere is not uniform, it is divided into three main parts based on differences in composition: the core, the mantle, and the crust. The dense or heavy inner sphere is the core. The less dense is the mantle. And the lighter thin part is the crust, which is not uniform in thickness. It is thinnest beneath the oceans and thickest beneath the continents.
The crust and the uppermost mantle make up a rigid outer layer called the lithosphere, where the rocks become partially melted, which are able to flow slowly because of the uneven distribution of heat deep within the earth. This region is called the asthenosphere. Beneath the asthenosphere, the rock becomes stronger again, and this region is called the lower mantle.
The last subsystem of the Earth is the biosphere. To define the biosphere, what does bio mean? Correct. Bio means life or living things. Thus, the biosphere includes all life on Earth. It is concentrated in the zone that extends from the ocean floor upward for several kilometers into the atmosphere.
Plants and animals depend on the physical environment for life. However, organisms do more than just respond to their physical environment. Through countless interactions, organisms help maintain and alter their physical environment. Without life, the makeup and nature of the solid Earth, hydrosphere, and atmosphere would be different.
So those are the four subsystems of the Earth. Let's have a brief recap on our topic for today. We have hydrosphere, which includes all water found on, under, and over the surface of the Earth. The atmosphere, which are the gases that surround the Earth, or commonly known as the Earth's air. The geosphere, which is the solid Earth, and biosphere, which includes all the life on Earth. Now it's time to test your understanding of today's lesson. Prepare a ball pen and a piece of paper to answer the following questions. I will repeat each question twice, and you will be given 5 seconds to answer each question. Ready? Let's begin.
Number 1. Which of the following is not one of the four major geological subsystems of the Earth? A. Biosphere. B. Geosphere. C. Atmosphere. Or letter D. Watersphere. Again, which of the following is not one of the four major geological subsystems of the Earth? A. Biosphere. B. Geosphere. C. Atmosphere. Or letter D. Watersphere. Number 2. Which subsystem helps regulate the temperature of the Earth so we do not experience too much hotness or coldness? A. Biosphere. B. Geosphere. C. Atmosphere. Or letter D. Hydrosphere. Again, which subsystem helps regulate the temperature of the Earth so we do not experience too much hotness or coldness? A. Biosphere. B. Geosphere. C. Atmosphere. Or letter D. Hydrosphere. Number 3. In which subsystem do bodies of water surrounding the Earth belong? A. Hydrosphere, B. Geosphere, C. Biosphere, or letter D. Atmosphere. Again, in which subsystem do bodies of water surrounding the Earth belong? A. Hydrosphere, B. Geosphere, C. Biosphere, or letter D. Atmosphere. Number 4. Which subsystem contains all living organisms of the Earth, including those on the land, in the water, and air? A. Biosphere, B. Geosphere, C. Atmosphere, or letter D. Hydrosphere. Again, which subsystem contains all living organisms of the Earth, including those on the land, in the water, and air? A. Biosphere, B. Geosphere, C. Atmosphere, or letter D. Hydrosphere. Number 5. What is the name of the thin layer of solid rock that makes the outermost part of the Earth? A. Core, B. Mantle, C. Crust, or letter D. Biosphere. Again, what is the name of the thin layer of solid rock that makes up the outermost part of the Earth? A. Core, B. Mantle, C. Crust, or letter D. Biosphere.
Congratulations! Now we are finally done with the short quiz. Please submit your papers to your respective subject teacher via messenger, email, or submission on your next module distribution. And that ends our lesson for today. I hope you enjoyed and learned something. Again, I am teacher Giselle Esquinas from the San Luis Oriental General Comprehensive High School, Senior High School, Division of the San Luis Oriental. Tune in for another learning episode next time. Bye!
Audio Jungle. Audio Jungle.
Good day, learners! I am teacher Hannah Napitan of Misamis Oriental General Comprehensive High School, Division of Misamis Oriental. I am your teacher for this learning episode on Earth and Life Science. Before we move on today's lesson, let us have a quick recap. What is the difference between a mineral and a rock? Minerals are naturally occurring inorganic solids that have a crystalline structure and definite chemical composition. Rocks are made up of naturally occurring aggregate of one or more minerals. Now, guess our next lesson by looking at the pictures. What word describe the images? Correct! Types of rocks. In today's lesson, we will classify rocks into sedimentary, metamorphic, and igneous rocks. Rocks are found everywhere in the Earth's surface or beneath the Earth's surface. The rock cycle transforms rocks into the three types of rocks, namely sedimentary, metamorphic, and igneous rocks. The first type is sedimentary rocks. Sedimentary rocks are formed from sediments deposited over time as layers at the bottom of lakes and oceans. Weathering and erosion has broken down rocks into sediments. The sediments can be minerals, small pieces of plants, and other organic matter, pre-existing rocks, or pieces of remains of living organisms that accumulate in Earth's surface. These sediments are compressed over a long period of time before they combine into solid layers of rocks. Sedimentary rocks cover most of the rocky Earth's surface and less amount of the Earth's crust. The second type of rock is metamorphic rock. How are metamorphic rocks formed? Metamorphic rocks are formed when it is exposed to extreme heat and pressure. This heat may be caused by magma or by intense collision and friction of tectonic plates, which led to the changes in their mineralogy and texture of the rock. The third type of rock is igneous rock. How are igneous rocks formed? Igneous rocks are formed when magma beneath the Earth's surface are ejected through volcanic eruption. As it reaches the Earth's surface, it is called lava. The cooling of lava makes it hard, which forms the igneous rocks. As soon as new igneous rock is formed, the processes of weathering and erosion begins, starting the whole rock cycle over again. So, what are the three types of rocks? The three types of rocks are igneous, sedimentary, and metamorphic rocks. Now that we have finished our learning episode, it is time to check our understanding of the day's lesson. Get a pen and a paper to answer the following questions. Are you ready? Let's begin! First question. What type of rock is formed by weathering, erosion, deposition, burial, and lithification? Correct! The answer is sedimentary rock. Second question. What type of rock is formed by cooling and crystallization of magma? Correct! The answer is igneous rock. Third question. What type of rock is formed by application of high heat and pressure to existing rocks? Correct! The answer is metamorphic rock. That ends our lesson for today. I hope you learned many things. Once again, I am Teacher Hannah May Christine Binapitan of Misamis Oriental General Comprehensive High School, Division of Misamis Oriental. See you all on the next learning episode.
Audio Jungle. Audio Jungle.
day, grade 11 learners. I am teacher Alice Calupas of Visamis Oriental General Comprehensive High School, Senior High School, Division of Visamis Oriental. I am your teacher for this episode on Earth and Life Science. Before we proceed to our lesson, let us recall first metamorphism. Can you tell me the reason why rocks can change and form into a new rock? Very good! Because of the intense heat and pressure, another rock is formed. In this lesson, we need to describe how rocks behave under different kinds of stress, such as compression, tension, and shearing. It will explain the different behavior of rocks as it encounters different kinds of stress. Have you not wondered why there are faults, why there are mountains, and different landforms? These questions will be answered as we discuss the lesson ahead. Let's go and explore the beauty of Earth and Life Science. Do you know that rocks can be stressed? Stress on rocks is a force that changes the rock shape and volume. The first type of stress is compression. It is a type of stress where rocks tend to compress with each other. There is a tendency for the rock to be squeezed until it breaks or folds. This can cause the rock to shorten. Do you know the most famous example of compression? Correct! It is the Rocky Mountain in North America. The second type of stress is tension. Tension is a type of stress that influences rock behavior. It occurs in divergent boundaries. This time, the rocks move away from each other. Can you give me an example of tension stress? You get it right! The best example of tension stress is continent. Now, we are down to the third type of stress, which is shearing. It is the stress caused by pushing a mass of rock in two opposite directions that break or slip apart or changes its shape. It happens in transform boundary. Can you name one example of shearing stress? Very good! San Andreas Fault is an example of shearing stress. Another example of shearing stress is the Alpine Fault of New Zealand. The Alpine Fault is a geological fault that runs almost the entire length of New Zealand's South Island and forms the boundary between the Pacific Plate and the Indo-Australian Plate. Now, it's time to check your understanding of today's lesson. Get a pen and paper to answer the following questions. I will give you 5 seconds to answer each question. Are you ready? Let's begin!
Number 1. When does tension stress happen on rocks? Letter A. When rocks are pulled apart. Letter B. When rocks are compressed. Letter C. When rocks slip. Or letter D. When rocks are steady.
Number 2. Which type of stress formed the continents? Letter A. Compression. Letter B. Shearing. Letter C. Tension. Or letter D. Fault. Number 3. Which of the following refers to the type of force that changes the shape and volume of rocks? Letter A. Stress. Letter B. Shearing. Letter C. Tension. Or letter D. Compression. Number 4. Which of the following types of stress dominates the divergent boundaries? Letter A. Tension. Letter B. Compression. Letter C. Shearing. Or letter D. Fault. Number 5. The San Andreas in California is known for exhibiting which type of stress? Letter A. Compression. Letter B. Shearing. Letter C. Tension. Or letter D. Fault. We're done with a short quiz. Please submit the corrected papers to your respective subject teacher via messenger, email, or during the submission on your next module distribution. And that ends our lesson for today. I hope you learned a lot. Once again, I am teacher Alice Calupas of Misamis Oriental General Comprehensive High School, Division of Misamis Oriental. See you all in the next episode.